This is our first video in geometry. You'll notice up at the top here it says Geometry 1.1. That means first chapter, first section. That's why it's our first one. Points, lines, and planes is the title today, and that's what we're going to be talking about now. First thing we're going to talk about are collinear points. Co-line, on the same line. Points that are all on the same line are collinear points. Now, you need to have 3 of these, because you'll see down here there's exactly one line through any 2 points. So any 2 points are always collinear. You have to have at least 3, and they will line up in a straight line. That's called collinear. Now, non-collinear points, non-co-line, not on the same line, that would be any other 3 points that aren't on the same line. Just think about 3 points in your room. You can take 3 corners of your room or whatever, and you will notice they are not on the same line. So they are non-collinear points. Now, going down here, there's exactly one plane through any 3 non-collinear points. So take those 3 points that you were thinking about in your room, and if you take those 3 and they aren't on the same line, you can draw one plane through those 3 points. Now, if you take like 3 points in the top of your room, it's pretty obvious. The ceiling is your plane. If you take 3 points on the floor is your plane. But what if you take 2 points up top, 1 point down the bottom? Well, you can tilt that plane to run through all 3 of those. So you can always run a plane through any 3 points, no matter where you put them in your room or in the world, for example. Okay? Now, intersection. Intersection should be pretty obvious to us. We see it in real life. An intersection, when you're driving, for example. What are we talking about? Well, when you're driving along and you say, hey, we're coming up to an intersection, that's when another road crosses the road that you're on. That's an intersection. Well, it works the same way with lines. If 2 lines meet, they meet at an intersection. 2 lines, 2 planes, two of any type like that, line segments. Okay, if they meet at an intersection. Okay? Now, some geometric terms that we're going to talk about real life objects. Okay, a plane can be designated. You could talk about your desktop at school. That would be a plane. It doesn't look like a plane, but it's a designation or supposed to, represent a plane. The floor in your room or in the classroom, the ceiling, same thing. Those are all planes. You could say a wall also. Now, a flagpole. Flagpole is straight. That is a line. A baseball bat, kind of a weird one, but edge of a whiteboard or edge of your room. Go to the corner of your room and you go up and down, that's a line. Okay, the point, tip of the flagpole, that's a point. Corner of a room, okay, just 1 point down in upper corner or lower corner, doesn't matter. End of a spear is a point. That's a sharp one. All right, now we're looking at this figure over here, our box or cube. Rectangular prism would be the official term for it. Okay, and we have 6 planes on here. We have this top one. Okay, that's a plane. We have the bottom one. Same size and everything. We have our left side, and we have our right side. That's 4. And then we have our front, and we have our back. So we have 6 planes here. Now, which of those planes is parallel to ABCD? Well, ABCD is our front, so we just go to the back. EFGH would be parallel. What lines are parallel to EF? Notice EF is on the back here, top, back. Well, pretty obvious, AB is parallel to it. Parallel, remember, think of railroad tracks. Okay, EF is also parallel, should be pretty obvious. Down on the bottom here, GH is parallel. The one that people might miss is EF is parallel to DC. Okay, that's our 3 choices over there. Now name 3 collinear points. That would be right here. F, G, and J are collinear. They're all on the same line. Alrighty, talk to you later.